In this video, I'm going to talk about a review of how we add and subtract rational expressions. So remember that rational expressions are just fancy-looking fractions that involve polynomials. So when we add or subtract rational expressions, we're going to add and subtract them in the same way which we would add or subtract a polynomial. And that is we have to make sure we have a common denominator. So in this first example, I do have a common denominator. So all I need to do is then add my numerators. And I do that by combining like terms. Okay, so when I add here, I see that I end up with an x squared. I have a minus 5x and a minus 3x, so together that's a minus 8x. And then a minus 6 and a minus 10, so that's minus 16. And my denominator, of course, stays the same, which is 2x squared minus 7x and then minus 4. Now, always when you are adding or subtracting your rational expressions, you need to make sure if you can simplify, then you should. And the way you can simplify is by factoring the numerator and the denominator and canceling out any common factors that they have. So first let's think about, can we factor this numerator? So I'm thinking, are there two numbers that multiply to give me negative 16 but add to be a negative 8? So think about how you make 16. Well, there's 1 and 16. There's 2 and 8, and there's 4 and 4. And of course, negative 16 would mean that one of these has to be negative, but not both, okay? So your gut may tell you, oh, okay, I'm going to use the 4 and 4 in order to get my negative 8, right? Negative 4, negative 4. But the problem would be here, negative 4 times the negative 4 would really be a positive 16, not negative. So therefore, our numerator is not factorable. And so we leave it just as is, like this. Doesn't matter if the denominator can factor. If the numerator can't, you just leave it. Okay? So now let's look at this second problem. And let's think, okay, how do we find the least common denominator? Well, first steps is that you need to factor each part of the denominator. So this first one, it factors into x plus 2 and x plus 1. Okay, the second one here, it factors into, change my pen here for a second, x minus 2 and x plus 1. And then this last guy here, he factors into x plus 2 and x minus 2. So my LCD for this problem would be an x plus 2 and an x minus 2 and an x plus 1. Okay? So now what I need to do is I need to figure out, okay, what is it that each numerator, what is it that each fraction is missing? And that's what I multiply it by. So when I think of this first guy here, I have an x plus 2 and an x plus 1, so what it's missing is x minus 2. So I multiply the top and the bottom by x minus 2. I have to squeeze it in there here. X minus 2. Okay, good. The second one, I have an x minus 2 and an x plus 1. What is it missing? That's right, x plus 2. So top and bottom. And then this last one, I have an x plus 2 and an x minus 2. It's missing the x plus 1. So top and bottom. Okay, so I'm going to simplify the numerator now and see what I get. I'm going to multiply these out. I have a 5x and minus 10. Okay, that's 5 times that x minus 2. The second one is a little tricky. I have a 7x and a 14, but remember I'm subtracting that second fraction. So I'm going to end up with a minus 7x and a minus 14. Okay, and then my last one, I'm adding it, and I have a 4x and a 4. So 4x plus 4. Okay, and that all is over my denominator, which is common denominator of x plus 2 and x minus 2 and x plus 1. All three together. So now I'm going to combine my like terms, 5x and a minus 7x and a plus 4x. So that gives me minus 2x and a plus 4x. That leaves me with a positive 2x. Then I have a minus 10 and minus 14. That takes me to negative 24. But then I'm adding back 4, so that's minus 20. And again, my common denominator, x plus 2, and x minus 2, and x plus 1. Okay. Now I can factor this numerator because it has a common factor of 2. But what you'll see is that doesn't allow me to cancel anything out. But if you write it this way, that's fine. If you leave it as the 2x minus 20, that's fine also. Either one of these I would be fine with. Okay? Let's take a look at one more. On this one, again, I'm looking for a common denominator, so I want to make sure that I factor the denominators first. Okay? So let's take a look. This is difference of two squares, so that turns into x plus 9 and x minus 9. Now these are those tricky ones. This looks like an x minus 9, but they're in the wrong spot. So what it really is a negative 1 times x minus 9. If you recall that when they're in the opposite positions of one another, if you factor out a negative 1, it helps change the sign of them, and so it changes the spots. Okay? So my LCD for this problem is going to be just x plus 9 and an x minus 9. Now you may be thinking, okay, well, how do I deal with that negative 1? Well, it depends on how your previous instructor taught you, but what I taught my students was this negative 1 can come up to the numerator and get multiplied through. Okay, so what I really have here is I have 7x over x plus 9, x minus 9, and then minus that negative from the denominator comes up and he gets carried through the numerator. So negative 2x minus 1. I don't need parentheses there, but I put them anyway. I guess I can erase them. Whoop. Just like this. Okay, and then I have x minus 9. So what is my second fraction missing in order to be able to move forward? Well, sure enough, he's missing an x plus 9. Okay, so we multiply top and bottom. All right, good. So what does that leave me with? Well, I have a 7x, and then I have to multiply this out. Okay, so, and don't forget I'm subtracting it, so I have to subtract the whole thing. So I have a negative 2x squared and a minus 18x and a minus 1x and a minus 9. Okay, and that is all over my common denominator of x plus 9 and x minus 9. So then we simplify, combine like terms. I have to carry this negative through all parts of that parentheses there. So when I carry it through, it's actually changing all of these to be a positive sign. So what I'm left with is a 2x squared, because there's no other x squareds. I have a 7x here, but then what I end up with over here is another 19x, so that's plus 26x. And then I have, again, I'm carrying that negative through to this 9, so that's plus 9. And I keep the denominator the same, x plus 9 and x minus 9. Now again, remember you should check to see if you can factor that numerator, but in this case you can't, so we're just going to go ahead and leave it. So I hope this was a helpful review on how you add and subtract rational expressions. We will most definitely be using them in the future with the next few sections where we are going to be solving rational equations. Keep up the good work. We'll see you soon.